fix that up. All right. So I haven't figured out a way in the calendar to, because last week we talked about doing Monday, Tuesday, Thursday, Friday. So it still shows Wednesday, but I don't know if I'm going to have to book a whole bunch of Mondays, a whole bunch of Tuesdays, a whole bunch of Thursdays, and a whole bunch of Fridays, but we'll cross that bridge when we get to it. Last week, I think we finished everything we needed to in Chapter 8. Chapter 9 is naming. I don't know, where am I looking? And which you've done a bunch of naming already. Looks like chapter 10 is the mole, which is a unit conversion thing. 11 is equations. So if you've been into the teams thing, let's pre-calc in here. Yes. So there's two files for chapter 9. Um, that's because I uploaded those. The notes, which is the important pages. The naming compounds one is the stuff where the practice is, and we'll talk about that. Now that I have that open, I might as well just open it over here. You're going to open it up and you're going to say, holy crap, you're insane, because there's 10 pages. This is normally like well, last year it took a little longer because they didn't have Madame Walsh, most of them, for Science 10. The core English kids were better off last year because the person the year before for Science 10 wasn't the best. But there's all sorts of them. We're not going to expect you to do everything. The last two pages are gravy. That's 200 things. So don't worry too much. Well, naming is important. We need to know how to name things. So we'll probably make sure we have some stuff on it. I may try to fiddle around with like forms and get you to do quizzes and whatnot, because you can name or type things in and I can check, but I don't know if I'll do that. I've heard things from other teachers that some people are having issues uploading assignments and accessing files from Teams, but I've heard of one person had problems uploading, but I think that was an internet issue, not a problem with the program. If you have a problem with the program and you can't get something uploaded, or it's not shown, like you don't think the right files are there, let me know. And if it's an assignment that you have to do, you can just email it. And also the deadlines, I have to put a deadline in there for them. If like it's not like things are being marked, it's like, okay, well, Jaden's the one who's got her initials right there.
Are we gonna do that?
What?
That page you showed us?
Well, you're going to do, well, you won't, if for an assignment for this section, I've got other files that I'll use for assignments with naming. That's just practice. So how I normally do this is we go through ionic compounds, naming and formulas, and then we do practice 1. Practice 2 is transition metals. Then we talk about polyatomic ions. Practice 3, like I have all of or a lot of the answers, I guess. There was a quiz. Molecular compounds are easier. So we're going to go through and we'll probably spend a day and a bit on ionic compounds to make sure we get some practice. And you can ask questions if you need to, and I'll post some answers, because naming is something where there is a particular answer. Like some of the structures on that assignment, you can potentially do more than one structure and have it formally be right. There's what it actually is and what it could be, but naming is usually a binary, it's right or it's wrong, because like this kind of bit up top, um, like there's so many different compounds. Naming has to be done fairly rigidly. Although, ironically, there's like last week we talked about like carbon tetrachloride, which was CCl4, but there's one CH2Cl2. Um, there's a number of different names for that: methylene chloride, dichloromethane, 1,1-dichloromethane, and so there's more than one name for a bunch of things. Um, but our goal is to teach you what we call systematic naming, and there's um, books that the organization that kind of regulates, well, not regulates, regulates is an okay word, chemistry. It's called the International Union of Pure and Applied Chemistry. And they have meetings that they go through, and there's committees and groups that say, this is how these compounds should be named. This is how these compounds should be named. And I've got some of them somewhere. It's a PDF. There's a red book and a green book and a blue book. I'm not going to spend all sorts of time trying to find them, but they're hundreds of pages long because they deal with all sorts of things. We in grade 11, what? My battery's dead again? That was weird. Um, we tend to stick to what are called binary compounds. That's not what I wanted. We we start with binary ionic compounds, binary molecular compounds. We can have polyatomic ions um, when it comes to ionic compounds, but we don't get into anything too big and crazy. So it's a process. I'm just checking. Oh, it says the battery's good. I don't know. Maybe this airliner's on its last legs, and I'm gonna have to. Hopefully, it doesn't die, and I don't have to replace it. So people have decided how things are named. I will teach you the rules as I know them. Um, you can have, if you go to university, have older professors that sometimes use old-fashioned names. When we did ions, we talked about now iron, not IROM, iron 2, whatever, iron 3, whatever. Like when most of the people who use the old fashioned ferrous, those two are equivalent. Most of the people who use those a lot are probably retired now, but still some people, there's hangovers, like older people and whatnot who are still teaching. So you have to remember about that. So too many compounds to remember the names of them all, so we do rules. Two or more elements, it's about putting atoms together. The name tells us somehow how many and what type of atoms are there. For molecular compounds, it's nice and simple. For ionic compounds, we have to know a little bit. Well, I think about that. I'm going to look for my periodic table just in case. Hopefully that opens it. Excellent. Because we're going to need that here in a minute. Atoms. We're not talking about individual atoms. They're neutral. We have protons and electrons, and that's all that stuff. And it's all about how electrons move. If it's an ionic compound, it's, whoops, cation, anion stuck together, or kind of more generally, Me, metal, non-metal. And then we have, like, this is just about the transfer of electron. Technically, we apparently can't talk and write at the same time. Um, the smallest pieces of formula unit because remember, it goes off in all directions and repeats, but it's like the simplest fraction. It's the smallest ratio. There's 14 billion sodium atoms, there's 14 billion chloride atoms, but the ratio in which they occur is 1 to 1, so we say the formula is NaCl. Molecular compounds are straight up nonmetals made by joining atoms together, many, multiple. We're only going to look at binary molecular compounds that have two types of atoms, but we can have them that have a slew of different things. Formula unit, the smallest ratio, and that's kind of the idea. Uh, that's a sodium ion. That's a chloride ion. There's one of sodium for every chloride. In a molecule, the molecular formula tells us the exact number and kind of atoms. CO2 is 1 carbon, 2 oxygen, always. Glucose is 6 carbon, 12 hydrogen, 6 oxygen. There are other hexoses that, sorry, that's going to drive me nuts. Oh, good, my mother. Don't ignore your mother, but ignore your mother. Well, ignore my mother. There's a bunch of different ways that that can be built into something, but generally speaking, each one has that particular arrangement. So we're going to, we talked about polyatomic ions a little bit. Okay, we're going to, polyatomic ions you will find, hopefully there's not a whole lot, but they're all in this table. Acetate, ammonium, benzoate, bromate, carbide, etc., etc. Uh, they have a particular charge. We talked about them in chapter 7 in their groups of nonmetals that have a charge. In chapter 8, they're all, with the exception of the chromium ones and permanganate, wherever that is, they all are nonmetals. So the O and the H here are held together with a covalent bond, but they have that whole thing has an extra electron that makes the whole thing negative. So this is a list of some of them. There's tricks to any polyatomic that has a charge bigger than -1. We have phosphate, phosphite, carbonate, sulfate, sulfite. This is going to work for not really chromate, but we have hydrogen analogs. I don't know if there's any on the periodic table. Oh, here we go. Go away. That's not what I wanted to do at all. So phosphate somewhere here is PO4 -3. A hydrogen ion has a charge of +1, so if I add one positive one, I get HPO4. 2 minus, if I add 2, we get H2PO4 -1. And you can do the same thing with sulfate and hydrogen sulfate, sulfite, hydrogen sulfite. The nitrites don't work. Carbonate, hydrogen carbonate, most of you probably have a box of a compound of that in your either fridge or cupboard. Sodium hydrogen carbonate is baking soda. Technically, you can do it with peroxide and persulfide, but not very common. So sulfate is SO4 -2. If I add a +1, hydrogen sulfate is H, SO4 -1. Hydrogen phosphate is HPO4 -3 plus 1 is -2. Dihydrogen phosphate is adding another plus -1. Oh, the most common positive polyatomic ion is ammonium, which is made by adding an H plus to ammonia. Old notes, the old periodic table it had on the back. Be thankful you don't have to memorize them all like I did because my teachers didn't like us as much. So, binary ionic compounds you did in grade 10. We talked a little bit about these in chapter 7 when we did ionic bonding. 2. Binary. 2 element types. Because a bicycle has 2 wheels, a tricycle has 3. Well, car has 4, but that's a whole other thing. So an ionic compound are obviously ionic, an anion, and a cation. If I have an anion or a cation, sorry, in group 1, I know its charge is +1. I know its charge is +2, +3, -3, -2, -1. With ionic compounds, we know what the charges are. So we say what elements are there, and that tells us, because we can work backwards, well, if it's this particular thing, then it has to have this many and whatnot. That's what we'll get to when we write formulas. The name is the name of the ions. The cation or metal always goes first. If you write ClNa, I will straight up mark it wrong. Um, Even though I won't. Well, I will look at things. If you do an assignment, I'll probably say your answers to questions 1, 3, and 6 are not correct. Everything else looks good. The cation goes first, anion goes second. For the A group elements, they're nice and straightforward. This is the main group, not transition metals. So Na is the sodium ion. So sodium, Cl is Cl minus 1, chloride. MgBr2, well, Mg is magnesium because we know that this becomes, or magnesium ions are 2 plus. Bromide, we know bromide is -1. Sorry, I thought I heard a baby crying. All right, maybe I did. I don't know. It's Brittany's turn. So Br is -1. And when we're writing a formula, I know bromides are all -1. I know magnesiums are all +2, so based on that, I can figure out the formula. Na, just like up there, is sodium. S comes from sulfur, which becomes sulfide. So writing these names is usually fairly straightforward, um, and hopefully doesn't take us a whole lot of time. Oh,
So why is it turning to mod?
I'd
Yeah.
any of the elements. Oh, that's not the one I wanted. Way over on this side, the names of any anion, you change the ending to "ide," and that's just the rule that somebody made up years and years ago. So fluoride, chloride, bromide, oxide, sulfide, selenide, nitride, phosphide, arsenide, and so on and so on. Well, really, generally, any anion has to be on the right-hand side of the staircase. You're not going to have antimony as a negative, but Telluride. I always laugh when if you see a Kia Telluride. Well, that's a car. Telluride is a place in Colorado. Well, tellurium is an element. Whether or not you can find it in Telluride, Colorado, I have no idea. But the anion of tellurium is telluride, and that's just the rule. So that's naming. This formula writing is generally straightforward. Transition metals are the problem because anything in group 1 way over here is always plus 1. Anything in group 2 is always plus 2. If it's in this 3b, it's usually plus 3, but I've seen compounds of scandium that are plus 1. These can be all the transition metals you have to communicate a charge. So we need, if it's a transition metal, oh, Kate is definitely awake. So we put a Roman numeral. The compound has to be neutral, so we have to figure out effectively. We know the negative charge. If it's oxide, oxide is -1. Chloride is -3. Sulfide is -2. Oxide is -3. We work backwards because I need to know what charge copper is in this one. We know oxide is -2. So the charges have to balance out. If oxide is -2, in this case, copper has to be +2 because those sum to 0. So if the copper is +2, we'd say it's copper with the Roman numeral. I have a hard time doing this. 2, oxide. I'm going to go through these quickly, then we're going to write some names. And formulas is pretty much straightforward, and that's kind of where I want to get to today. Chloride is -1. In COCl3, we have 3 minus 1s, so 3 minus 1s, the total negative charge is -3. If the total negative charge is -3, the total positive charge has to be the same magnitude, which is +3. So the cobalt is +3, cobalt 3, chloride. When you have multiple metals, it gets a little bit trickier, but it's okay. Cu2S. Well, sulfide is right below oxygen, and all of these charges, remember, for an anion, -3, -2, -1, always. They're not going to change. The negatives never change. It's just those silly transition metals. So if the negative charge is -2, the total positive charge has to be +2. So the two coppers in total have a charge of +2. Well, I have two of them. I have to split that equally. So each copper has to be +1. Copper 1. Uh, Kate woke up and is looking at me funny because I have headphones on. All right. Iron Fe2O3. Oxide again is -2. 3 -2s is -6. So the two irons have to be +6. Well, if I split +6 evenly into two pieces, each one is +3. Let's put it in the blank. Iron 3. I tend to not cross those off because my penmanship is so awful. Hopefully you don't have that on your car, but if you do, like me, it's rust and it's generally not good. So one of the things I'm going to ask you to try uh, today um, is practice 1 and 2. We're going to simplify it to just the left side of the page instead of the whole thing. It is writing names. Practice number 1 is all ones like those, which are the A group. So practice number 1, if we go over here, naming binary ionic compounds, these are all um, group 1. So there's no transition metals on practice number 1. Practice number 2, everything is transition metals. So ultimately we have to be able to look and say, well, I see potassium, sodium, sodium. Those are the A group ones, so I don't need a transition metal. So write the name. Well, what is K? And this is where in class you would be doing this rather than me, Chloride. Sodium is Na. Nitrogen becomes nitride. Sodium, Na2Se, again, sodium. And Se is, so these other four, hopefully I switched colors. Nope. Fine, be that way. We'll do it that way. These four are all, well, those two are transition metals, obviously, because they're over here in the middle. Lead, on the other hand, is way down here. It's technically not a transition metal, but it's a metal below the staircase. And technically those six, when they make ionic compounds, can have multiple charges. Uh, these are common charges, and it's something that we have to worry about. I think the legend is up here. It says most common charge. Just because it's the most doesn't mean it's always going to be like that. But lead can be +2 or +4. So if it's any one of those, really the five green ones, because you're not seeing a whole lot of ionic compounds with antimony, we need to make sure we have a Roman numeral. So up here we said, I'm going to just worry about these anions. Nitride is
So like, how do you know that you have to have a?
for, so Roman numerals when we did ion, like forming ions and all of that. All of the transition metals always have a Roman numeral, with the exception of zinc is always +2 and silver is always +1. Cadmium is like 99 point whatever percent +2, but there are the odd occasion. So these are the only two that you're not going to put a Roman numeral with, and the five that are on the other side. And technically, because these ones,
Sorry, I don't know what the heck just happened. Like they like kicked me out.
okay,
I come back in.
I didn't do anything, I swear. I can mute you, but I can't kick you. Well, I don't know. I'm sure I.
They like kicked. I don't even know what happened. They like kicked me out for something.
Oh well, internet. So it's just about remembering when we did the period. This is where chemistry builds on itself. When we did earlier stuff, we talked about group names. I forget. I think that was part of chapter 5 or 6. Any transition metal, with the exception of those two, needs a Roman numeral. The exception for the main group, because there's always, is bismuth, lead, thallium, indium, and tin. Technically, all need Roman numerals. So knowing that, I see chromium. I know that's a transition metal. Scandium is a transition metal. Lead is one of those. The better term is multivalent because that means they can have more than one charge. Nitride is -3. Phosphide is also -3. Oxide is -2. So I know nitride is -3. I know that's going to be the back side of this one. If nitride is -3, chromium has to be +3. So we say we put a Roman numeral of 3 in there. Sorry. Phosphide is also -3. So two -3s is -6. So the scandium have to be +6. So +6 split over 3 ways. This is scandium 2. Oxide is -2 always. Well, that one's nice and simple. This is just a contrast thing. So if oxide is -2, there's one of those. There's one lead. This has to be lead plus 2. And if oxide is -2 and there's two of them, they have to have -4. So the lead has to be +4, which is IV. If you have to look up the Roman numerals, don't worry. Well, you don't generally deal with lead a whole lot. One of the labs I had to do in university, we made a compound one week that we was called, or the formula was SNI4. The very next week, we took the exact same, we made it from tin and iodine. We took tin and iodine under slightly different conditions, and we got SNI2. And then we had to characterize and all of that because different conditions yield different things. So that's naming. That's the top half. So I would suggest just do, like, if you have time, look at the left side. I'll come by tomorrow, go over them. The only way you get good at this is doing it. Why am I quicker than all of you at doing these? Because I've been doing them since I've been in grade 11, or took grade 11 chemistry, which was a long time ago because I'm old. Or writing formulas, same idea. The charges have to add up to 0. So we have to know the charges. Anions are either the periodic table or polyatomic ions, because even if it's polyatomic ions, it's the same idea. Cations, if it's the name, if it's group 1, periodic table. So this is the A group, this is the B group. We'll talk later this week about polyatomic ions. Yeah, because we have to do brackets. Calcium and chloride. Well, I know calcium is Ca. Chloride comes from Cl, which is that. So I know my symbols. So I go to my periodic table and I go, let's zoom out because I really don't need the whole that. Calcium is in group number 2. If it's in group number 2, it has a charge of +2. Chloride is way over on the other side, is in group 7. So that means it gains an electron, so it becomes a -1. So we have 2 and -1. Well, that doesn't make sense. We need technically a second -1 to balance everything out. And this is where we did the calcium has 2 electrons and it gives one up here and one up there and all the dot diagrams. Calcium is Ca and that is Cl2. I'll do lithium sulfide because it's fairly straightforward. Whoa. My wife went and picked up her fancy, like if you were here this morning, space age chair, which is actually, even though it costs an ungodly amount of money, um, it was super comfortable. She's not going to let me use it, but I'm going to steal her other one and maybe be a little more comfortable. Lithium is in group 1, which makes it +1. Sulfide is in group 6, which makes it -2. How many +1s do we need to balance the -2? We need 2 of them. So 2 times +1 is +2. Li2S. And that's it. These ones all have Roman numerals. If it has a Roman numeral, what's the charge of tin here? 2. The charge of tin there is 4. 3. 3. If you have a Roman numeral in your name, which is what you're going to see in this one, other than silver, 2, 2, 3, 5, 4, 1, 3, yada, 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 you use that as the charge, or you have to figure it out. So this one I have, and this step, if you are just kind of getting back into it and need to write this down, go for it. That's the starting thing. If you can read a formula, and some people will do +1, -2, and just go that way, sure. it's a process, it's a practice thing. So tin is +2, oxide is -2. Well, +2 -2 is 0 already. SNO. Tin here is +4 or 4 plus. This is -2. Well, if this is +4, -2 doesn't balance it. I need to have two of those to balance things. And it's when you have charges that are big or even numbers. This is where I'm sure some of you have heard this silly crisscross thing, which drives me nuts, and I'm sure Mrs. Parley nuts as well. It's a sum of charges. It's got if you crisscross these, you're going to have the wrong thing. Just outright, iron is +3 in both of these cases. When when your kids get mobile, it's awful. She doesn't stop. She's going to be like a holy terror. Phosphide is in group 5, so it's -3. Sulfide is in group 6. Duh. So that's -2. Well, this one works out nicely. +3 -3 FEP. This one, not so much. An odd and an even number is generally bad news. But this is
It
a,
has to be 2 and 3.
it has to be 2 and 3. It's a lowest common multiple thing. I need 2 plus 3's, because if I have 2 of those, I get +6. I need 3 of these to get -6. So those are those formulas. So, well, I just said left side because I'm left-handed and my thing is to that. And what I'll do, even though I have like them all answered, I'll probably go through them all, or at least the left-hand side tomorrow, because we're pushing 45 minutes and I don't want to take up a whole bunch of time. So my suggestion would be normally I no, I don't have them. I would have these all printed out, but you can just number 1, 2, 3, 4, 5, 6, 7, 8. However many there are, there might be 10. When I do it tomorrow, I'll make sure I number down the sides and like I'll go through those ones. I would write KCl and then a dash and what it is and all of this. This one here, NaH, H is hydrogen. No, right. Hydrogen, even though it's way over here, we normally take an electron away. Technically, you can add an electron to give it 2 and make it look like helium. Fluorine becomes fluoride because we added one chlorine, chloride. Hydrogen, and I'll put it over here. If you have, I don't know, that's NaH, KH. If this is H minus 1, this is, wow, that was written poorly. I have to write it again. I'm sorry. That's still not that good, but H minus 1 is hydride. They're generally unstable. They react with water, but they exist. I've seen potassium hydride. I've used sodium hydride. Um, it's perfectly fine. Well, it's not perfectly fine, but so kind of homework practice. If you remember this and this clicks and you had Science 10 probably second semester last year and all of this stuff makes perfect sense, just do a couple of them. If you don't really remember, do a few more. Because it's why, like Mrs. Parley and I both use the same kind of first or similar. I might have been a dink at some point and changed things. She doesn't have this page, but this is all of them put together. So we'll give you strategies eventually to identify things and then go from there. But it's this unit in particular is about practice because that's why we give you hundreds of them because the only way you get good at naming, especially something that's systematic and it's the same thing over and over again, is by doing practice. And I know it sucks, and I know, well, it's here, it's like 9 degrees. You'd much rather be outside, I don't know, raking your lawn or going for a bike ride. Just do a couple of them. I don't expect you to do everything, and it's the more you do, the better. We'll probably do a short assignment that might be like 5 names and 5 formulas um, later this week, but nothing too long. I think that first assignment might have been a little bit too long. Um, if you have problems with accessing or uploading that assignment, let me know. I would prefer it if you could upload pictures of it to the Teams page um, because then I can just go through and I can send you feedback directly on there. Um, but if you can't, send me an email, let me know. And that's kind of all I wanted to get through today. Is any questions? I know it was fast and furious, but this probably would have been like, I don't know, that would have been a class at school with some time to practice. It's hard to tell because so many of you have microphones. I know why, and I'm glad you have microphones muted because if you didn't, it would be straight up chaos. Um, but you can unmute and answer question or ask questions. Anybody have any questions?
No, I'm good. No.
Oh, geez, I can barely see. My little video stays for you, and I just realized the screen was way up there, and it's like you can only see the top of my head. Oh gosh. Yesterday morning, Ben said, "Daddy, your hair, it's is your bald, your spot is gone. Are you growing hair back?" It's like, no, no, dude, no, I'm not. That wasn't very nice. But other than that, if nobody has any questions, that's it for today. We'll do some more tomorrow. We'll take Wednesday off, and then we'll do some more practice with polyatomic ions because that's really the only change with after we do those 2 practices is throwing polyatomic ions in, but it's really not a big deal. I don't want to show you all the answers, even though, hey, I'm recording this, so you can just go and cheat, but whatever. So if there's no questions, I'm done for the day. And go out, enjoy the sunshine,
Peace.
get some fresh air. Have a good day.